Now this is index creation and how to see the index information by using of this syntax here. And we created index on which column here? Salary column. Then after, okay, so what it was happen? Once you created index object, okay. So on which column are you applied your index? Okay. So that particular column data will arrange into B-tree format. It will be arranged. In which format it will arrange your B-tree. And this is actually the table. And now your salary column information it was here. Okay, right. So now after that, now after index was successfully created, now you can send your request. So what is my request here? Select star from EFP where salary is equals to 3,000. Okay, my this is my request here. Okay, so once you need to send after index creation, the request I'm sending here. And one more thing very important to remember, your index object on which column are you created, that column must be there under where class condition. Okay, so on which column you created your index, okay, on which on which column breaking up. Send your request here where salary is equals to 3,000. And here one thing should be remember what I'm saying here, on which column your index object is created. Based on that column only, you can retrieve your data. Okay, so for example, I created my index on salary column, but here, if I retrieve the information with MGR column or information with your e-name column, if you do like this, then your index scan will not be performed. Okay, na? So which column are you creating index? Same column should be used. Then only your index scan will be work. Otherwise, it doesn't work it. Okay. Now, and whenever you send this request to the server, what the server will do? Now your complete salary column information, whatever it was there here, this complete values are arranging into B-tree format. And how the B-tree format will be arranged here, observe. The B tree is nothing but binary tree format. Okay, so B tree format it will be arranged. So tree starts from what now? Root value. And the root value, how your database server will consider means as per the given conditional value. So on which conditional value basis are you retrieving your data? That value will consider as a root. That means your tree will be forming from that values onwards. The tree will be created. Okay, now? So now, and the 3,000 which was less than values are there, for example, the 3,000 less than values are saved under LP. LP calls a left pointer memory. It will be saved. And this is my 3,000 root value. And greater than values are okay, will be greater than or equals to values will be saved under right side pointers. So now the root started with 3,000 now. The root value starts with 3,000 and 3,000 less than values are keeping into left pointer memory side and greater than or equals to keep into right pointers. Okay. Then after, now we can come out and check. Now, in my salary column, which is the maximum highest salary in this? 5,000. So 5,000 is your highest salary. The highest salary we need to compare with the root 3,000. Now tell me, 5,000 is less than to 3,000 or greater than? Greater than. So that means the 5,000 it keep at the right side pointer. It will be kept into right side pointer. And the same as right side less than values are keep into left side pointer memory, and this is your 5,000 value, and which is greater than or equals to values are keep into right side. So this is called a root level and this is called a parent level. Okay, now? Right. And after that, next highest salary. What is the next highest salary? 3,000. But this 3,000 is having how many rows? 2 rows. First row, 7788, this is one row, and 7902 is a one more. So now the 3,000 value, next compare here. So when you comparing to root, the 3,000 which was comes under left side or right side? Right side, because greater than or equals to. So 3,000 will come to right side, but right side already parent is existing here. This parent you need to compare now. If you compare with this parent 5,000, then 3,000 will come left or right? Left side. So the 3,000 I kept into left direction. 3,000. But 3,000 is called a child level. In child level, your data can be saved here. And the 3,000 is in my table. How many rows it was there here? 2 rows. So every row is having unique row identity. Yes or no? Yes. So that row IDs we need to representing with a star. The first star of first row ID, comma, another star will represent another row ID. Your row IDs are nothing but page numbers. In your textbook, your page numbers, how we can say, your row IDs are just like a page number. And your first page number where your 3,000 is located, and this is your second page number where your 3,000 is located. Okay, so here, okay, here observe. Here, star is nothing but a star is represent star is represent what it is here? Row ID. Represent row ID. So that point should be remembered, and wherever I am keeping star, star is nothing but row ID. Here how many stars I am taking here? 2 stars. Why? Because my 3,000 is having in one row, this is one row ID number, and this is a one more row. So 2 rows are there. So that's a 2 row IDs. Okay, now the 2 stars I'm taking. Okay. The next, what is the next maximum salary? 2975. 2975, how many times here? One time. So let me come. So compare with your 3,000. 2975 will comes left side or right side? Left side. So left side it will be come. In left side, okay, again same as which is less than left pointer will save your 2975, and greater than or equals to it will be save right pointer. Okay, that is greater than or equals to. So this is left pointer. Okay, now right. Now next biggest value 2975 after what is the next biggest value? 2850. How many times here? One time. So compare with the 3,000. Which side? Left side. Left side already existing 2975. And compare with 2975. Which side? Left side. Okay. Left side. So here I'm writing now. So 28. How much here? 2850. 50. And here I'm using one star because one time it will be. Okay. This is what we called. Okay, right. And the next one, what is the next biggest value? 2450. How many times? One time. Let me come to compare with your root. Which side? Compare with the parent. Which side? Left side. So here, how much here? 2450. How many times? One time. Okay. Next. What is the next biggest value? Huh? 1600. 1600. How many times here? One time. So compare with 3000. Which side? Left side. Compare with 295. 2975. Which side? Left side. What is this? 1600. How many times? One time. Right. Next. After 16, what is the biggest value? 1500. How many times? One time. Compare with 3000. Compare with 2975. Left. So 1500. One star. Next. Next. 1500 after what is the next one? 1300. How many times here? One time. So compare with the root, left side. Compare with the parent, left side. So what is this? 1300. Only one star. Otherwise here, I will take into next line. You should take into one line only, okay? But here my space is not there. That's why I'm going to next line. Okay, next. After 1300, what next? 1250. 1250, how many times? Two times. Okay, compare. So 3000 comparison which side? Left side. 2975 left side. So now here I can go. 1250. How many stars? Two stars. And star is nothing but row ID. Now after 1250, what is the next one? 1100. 1100 how many times? One time. Okay. So 1100 also comes here only, na? Yes or no? 1100. So star. Next. What is the next one? 950. How many times? One time. So 950 also comes here only. Next. What is the next lowest? 800. How many times? One time. So 800. Okay. Right. So these are arrangement of your salary column data. Which format it was arranging? B tree format, binary tree structure format it was arranged. Okay, small value to lowest value it will be take and checking with your root and keeping into left or right. So now after keeping like this and arranging your data like this, then what it will do, now whatever the request is sending to your Oracle server, now Oracle server, what it will do, first it will go to salary column. On salary column, you already created indexes. So that index is called as here, this is B-tree index is created and the data arranging into this order. So now what happened, now we can check it out. 3000 comparing with the first level root. After comparison, what it was come greater than or equals to. Then it was come to where now second level parent. Parent to whom I need to compare here 5000. 5000 if I'm comparing it was come to left side. In left side 3000 is there? Yes. So 3000 is equals to 3000 matching. And in this matching of data, first 3000 is having into particular row ID. So this row ID number is showing here star. Star is nothing but what now? Row ID. Then what it will do, based on this row ID, your Oracle server directly jump to this row. Directly jump to this row here directly. So based on the row ID, directly jumping to that row and the row will be pick and sending to client. Same as after that, next one more is there. So next what it was happened, directly jump to next 3000. So based on row ID, next row will be pick and send it to client application. So that means in my table, total number of rows, how many? 14 rows. But 14 rows means these rows are searching or not searching? Not searching. These rows are not searching. This row is not searching. So out of 14, how many rows are not searching? 12 rows. So 12 rows of data is not searched by your Oracle server. It means that your 12 seconds of time is what? Saved. That is called as searching time will be saved. How much time saved here? 12 seconds. That means your output will be produced by Oracle server. Your output will be produced by Oracle server with how much time here? 2 seconds it will be written for us. Because there are 14 rows, 12 rows are not searching based on your index information, based on that row ID of that value, based on that it was directly jumping that row and picking that row and sending to client. Okay, like there are 12 rows, searching time will be saved here. Okay, this is what now indexes advantage. But the same scenario in table scan, okay, how much time it will take? 14 seconds, because there each and every row is checked. But in index, it is not necessary to check each and every row. Okay, na? So now tell me, which technique will be faster to retrieving the data? Index technique. Now write down below. So yesterday class continuation. Take some separate distance you can take, because yeah, my adjustment purpose I'm taking like this, but you have to take properly. Okay. So this is what we call the B-tree indexes working nature. And the second one, right down below, composite index. So here, what is the mean by composite? Okay, composite is nothing but a multiple. Okay, so when we created an index object based on multiple columns, then we called as here composite index we called. And what is the syntax of this composite index means? Create index and give it your index name on table name of now you can send your column name 1 comma column name 2 comma and so on. So like you can use any number of columns here. Okay, right. And now come back and see. So now example how to design here. Observe. For example, present on my EMP table, on which column we created your index now? Salary column, so that I can see only salary column only we created our index. Okay, na? And remaining columns are, there is no indexes. Except salary, remaining columns are non-indexed columns. So now are you created one more index now? Create index I2 on EMP table of the columns are what it was here, DEPT number, comma, job, for example. So any column, any multiple columns you can take. Suppose this time I'm creating my index, create index name on table name of multiple columns I'm using. So now the index successfully created. And let me come out and see whether your index is created or not. Created how many columns created? 2 columns, department number and job. Okay. So once you created your index on multiple columns, then how your indexes will be work, sir? How your index will be work internally? Okay. So internally your indexes will be work based on your leading column. That means, for example, if you need to test now to retrieving some data, so select a star from EMP where suppose job is equals to, I'm going to send your manager. But whenever we need to retrieving data based on job column, first what it will do, your Oracle server, on which column wise data is retrieval, that column is a indexed column or not, first check it out. And now it is a indexed column, okay. But later, after that, your 2 columns are there indexed. So then what it will do, when it was having multiple columns, then what the Oracle will go to check here, whether your required or retrieving column, is it leading column or non-leading column, it will be checked. When your indexes are having on multiple columns. Whenever your index is created on multiple columns, and your column, that means on which column basis are you retrieving the data, that column is in a leading position of column or non-leading column, it will be checked. Suppose if we are you retrieving non-leading column basis, are you retrieving your data, then here index scan will never work. Here it will be work which scan by default, table scan. So that means here job is also one of the indexed column. But which type of it is? Non-leading indexed column. Which type here? Non-leading indexed column. So non-leading indexed column basis, if you try to retry, still your indexes will not be activated. It will be taking what by default? Table scan only. Now this is what. But the same scenario, when I'm going to send, okay, EMP, where DEPT number is equals to some 20 I was given. Again, DEPT number is also one type of index column, but this is which type index column? Leading column. Leading means first position of column is called as the leading column. So now when we are retrieving the data based on the leading column, then it will be performing which one here? Index scan. Okay, na? This is one. Otherwise, the third testing. If are you writing like this, where DEPT number is equals to 20 and job is equals to, suppose I'm passing clerk. If I'm going to using this by retrieving my data based on these 2 columns, and which columns here? Job and department number. But whatever the 2 columns I'm using here, in this 2 column, you are using leading column now? Yes, sir. So that's why when you are writing conditions like this, it is also perform what now? Index scan. So that means finally what you understand, when you created your indexes on multiple column, while retrieving the data from that particular table, compulsory you mention leading column. If leading column is not mentioned, then your indexes are not activated. If I want to activate my index, compulsory leading column must be used in your where class. Okay, na? Right down below. So here, indexes or index scan will perform based on leading column only. Index. Right. What is unique index? Okay. Now, when we created an index object based on unique constraint, based on unique constraint. Okay. And already unique constraint we discussed. What is the nature of unique constraint? Duplicates are not allowed. So now by using unique index, we can we can restricted restricted duplicate values so that searching time, so that we can reduce searching time. searching time Okay, for example, just observe, suppose are you created one serial number and your serial number. But on serial number, if you applied unique constraint, one serial number is there is no unique constraint, and one serial number we have a unique constraint. What is the advantage here? One, and here also one. One, two, two, three, two, four, two, five, three, three, four, four, four. Okay, five and five. So now you can see, if I want to retrieve if any particular serial number of data, for example, test where serial number is equals to suppose 3, I'm going to call. When I'm calling serial number 3, if on serial number there is a no unique index, what it was happen? All complete data will be searched. So complete data means including duplicate also searching now? Yes or no? Yes, that means total how many values searching? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12. Total 12 values are searched, including your duplicates. But the same thing, serial number is equals to 3. When my serial number is having a unique, then how many searching? 5 only search. Why, sir? Because we are not allowed duplicate values. So whenever you restricted duplicates, automatically my searching time is also reduced. Yes or no? When you have a more duplicates, then searching time is also more. When you are less, you are avoiding your duplicates and unique data you maintain, then automatically your searching time is also same. So here 12 seconds of time it was taken because you have a duplicates here, and here it is only 5 seconds of time. So this is what advantage of what now? Unique. Right on below. So the syntax, what is the syntax of this? What is the syntax of this? Create and unique keyword user, unique index and index name on table name of a column name. Table name of a column name. Now you can come out and see one more table we have here, DPT. But on this DPT table, suppose I need to see whether indexes are created or not. I want to check it out here. DPT. What it was saying here? No indexes. There is no rows on this. Now I'm creating one index. Create. Which index I'm creating? Unique index UI on DPT of a DNAME column. So index successfully created. And let me see whether index is created or not. Created a what is my column name? Department name. What is index name? UI. So after index, unique index advantage is what now? Let me come out and see. If I want to insert into this table, okay, so now I'm passing 50 and I'm passing sales and HYD. So carefully observe the sales department already existing in my table. And on this column, which index is there? Unique index. And sales already existing. And again, same sales are you inserted. It means what? It's a duplicate. So allowed or not allowed? Not allowed. Now you can see to execute. Now unique constant is violated. What is your index name? UI. So whenever the duplicates are restricted, automatically my searching time also reduces. Right down below. In real time, these all are created by database administrators, okay, not developers. These indexes are completely preparing by admins. The next type, functional based index. So when we created an index object, okay, based on a function name, based on a function name, then we called as here functional based index. Now the syntax of functional based index here, observe. So create index, and now I want to give it my index name on table name of here I want to send your function name of we can send column name. Okay, now so this is what we call the functional base index we call, and we are using some function okay on particular columns along with the index creation. Okay, and now you can come out and see. For example, this is our table information. On this, one of my column is ename. Any one column as your wish. Suppose I'm creating your index I number 3 on EMP of here. My function I'm using here, upper function, lower function, anything you can use on ename. So now here I'm creating my index with the help of what now? Some function name. I'm using some function name. Which function? Upper function. And now once you created your index successfully created. After created, on which functional basis are you created your index on the particular column? The same functional basis we need to retrieve the data. Then only your indexes will be activated. Suppose are you calling like this, select a star from. What is my table name? EMP where what is the function here? Suppose lower of otherwise my function is what now? Upper na upper of ename is equals to if I'm sending Smith. if I'm sending Smith. But now upper function, what is the nature of upper function? Lowercase characters will converting into upper. So that means that this function will be written your name in capitals. But are you mention your data in a small? So condition matching or not matching? Not matching. Then what it was happen? You can see your data will not retrieve. Okay, na? Suppose the same thing. If in place of this, if I'm going to sending here the capital Smith, then condition will be true and it will be retrieving your data. So whose name is what now? Smith. Right on below. Example and go for testing. What no? Okay, functional based index here. And these all are comes under B-tree type of indexes. And next one, second one you can take a bitmap index. Bitmap indexes. Okay, so bitmap indexes, these indexes we need to create on which type of columns. Okay, now, right? Suppose when I want to create, actually in real time, what it was happen, your database administrators, when they created indexes on your table columns, first of all, these columns cardinalities are checking. What they're checking? Cardinality. They're checking what now? Cardinality. So which column cardinality will be greater than or equals to 1? On those types of columns we can create B-tree indexes to improve the performance of your database. And which column cardinality will be less than to 1? On those types of columns, the people will prefer bitmap indexes to improve the database performance. So that means on low cardinality of columns, B-tree indexes are not useful. It's not necessary to create. If you create also, there is no advantage for us. And if we created the bitmap indexes on high cardinality of columns, again there is a no useful. The technique is not a work. Okay, so that's why before they want to apply B-tree or bitmap, first the real-time people, suppose I want to apply my index on this column, for example, then first this EMP number column, what they need to calculated, cardinalities are calculated. If the cardinality showing greater than or equals to 1, then on this column, which index will be priorable? Which index will be priorable? B-tree index will be priorable to retrieving data fastly and improving performance of database. Suppose your EMP number cardinality is less than to 1, then immediately B-tree indexes are not created. They created what now? Bitmap indexes to retrieving data fastly and performance of database is improved. Okay, now, so this is first they are going to be calculated. Okay, then here come to bitmap indexes are generally we are creating on which type of columns, means that these indexes are created. These indexes are created on low cardinality, low cardinality Low cardinality of columns. Okay, bitmap indexes will be priorable to create on a low cardinality of columns. Okay, now the question will come to you. Sir, what is cardinality? What is cardinality? Okay, a cardinality is nothing but it refers, it refers, it refers the uniqueness. It refers the uniqueness values, the uniqueness values of a column. Okay, na? Otherwise, even though some people are called as here, it refers, okay, distinct values of a column. Distinct values of a column also it can refers. Okay, na? So uniqueness or distinct. Distinct means what we discuss. Distinct means allowed duplicates are not allowed. Not allowed. So that is one. And what is the formula? See the formula also very important. Observe. Cardinality of column is equals to number of distinct values in a column by number of distinct values in a column by number of rows in a table. Number of rows in a table. So this is my formula. What is my formula here? Number of distinct values in a column by number of rows in a table. For example, careful observe. Few examples I will explain to you. Now, suppose in first example, I need to calculate here cardinality of a EMP number column. Suppose my first column is EMP number. First, I need to calculate what is the cardinality of a EMP number. So now, careful observe. What is your formula? Number of distinct values in a column. Okay, now come back. So now, I'm going to call my table, select a star from EMP. Now, EMP number column cardinality I want to find out. Tell me. First one is what now? Number of distinct values. How many distinct values are there in the EMP number column? How many are there? 14. 14 values are there in this in this column. Okay, now all are distinct values. Distinct values means unique. Now okay. So 14. 14 by number of rows in a table. 14. 14 by 14 how much? 1. So now cardinality how much here? 1. When your cardinality is 1, what we need to prefer? B tree. So here bitmap is not suitable. Now, next I'm going to take here cardinality of a job. Cardinality of a job. Now check it out. Number of distinct values. 5 5 or not? Yes, 5 only. Number of distinct values are how much here? 5. 5 by number of rows. 14. How much? 14 zeros, 14 threes are, 14 fives are, 0.35. So 0.35 is a lower or higher? Lower. So that means here, this is high cardinality. Okay. So high cardinality preferable is what I'm saying here. High cardinality. Then we are using what? B tree. The people will be prefer B tree index. Okay. Now this is what now? Low cardinality. This is what now? Low cardinality. Low cardinality prefer what now? Bitmap. So this point should be remembered. So now tell me. Now I want to create my B tree index on which column? On which column? Job column. Okay, na? But what is the syntax here to create a write down? Syntax to create a bitmap index. Create bitmap index name on table name of a column name. This is your syntax, and let me come out and see. I'm going to create your bitmap index now. For example, now I'm going to create now. So create bitmap index and BIT on the table of EMP of which column here? Job. So now I just go to execute it now. What it was happen? Your index is created. Which type of index? Bitmap. And now we can call this you can call the index you can see. Now on job column, which index is created? Bitmap index is created. And now we can take this syntax below. You can write now. So now after creating of bitmap index, internally this job column data, how it was arranged here. How the B tree indexes are arranging particular column data into B tree format. Same as once I created bitmap index on particular column, this column data, whatever it was there, and the data how to arrange it by your Oracle. Okay, na? And that mechanism we will see in a tomorrow class. Okay, and tomorrow after this we start a normalization topic, and maybe this week Saturday, otherwise Monday, I will start a PLSQL. Okay, na? And PLSQL I required almost 15 sessions. So maximum your batch will be completed in the uh, end of this month, the 25, 24, like it will be complete. Understand now? Okay. Right, guys. So thank you. Thank you so much.